Picture this. You're standing by your window watching a storm roll in. Suddenly, a brilliant white flash splits the sky in two. You brace yourself, and then, 3 seconds later, crack. The thunder hits like a drum. But wait, why didn't they happen at the same time? I mean, they're coming from the same place, right? So what's the deal? Before we get started, check out the link in the description to download our ebook. Today, we're uncovering the surprising science behind why you always see lightning before you hear thunder. And trust me, the answer is way cooler than you think. Stick around, because by the end of this video, you'll know exactly how to calculate how far away lightning is just by counting. Let's dive in. Lightning and thunder. They're basically the ultimate power couple of weather. You can't have one without the other. But here's what most people don't realize. These two phenomena are actually telling you different stories about the same event. Understanding why lightning comes first isn't just a fun party trick. It's actually rooted in some seriously fascinating physics. We're talking about the speed of light, the speed of sound, and the raw power of nature colliding in the most spectacular way possible. And here's the thing. Once you understand this, you'll never watch a thunderstorm the same way again. You'll be able to predict danger, estimate distances, and impress your friends with your newfound weather wisdom. So let's break it down, starting with the star of the show, lightning itself. All right, so what exactly is lightning? Think of lightning as nature's way of balancing the books. Inside storm clouds, you've got millions of ice particles and water droplets all bouncing around like they're at the world's most chaotic dance party. As these particles collide, they create static electricity, just like when you rub a balloon on your hair. Except, instead of making your hair stand up, this creates massive electrical charges. The bottom of the cloud becomes negatively charged, while the top becomes positively charged. Meanwhile, the ground below is getting positively charged. And here's where it gets wild. The electrical difference between the cloud and the ground becomes so intense that the air itself, which normally acts as an insulator, can't contain it anymore. Bam! A channel of electricity explodes through the sky at speeds up to 270,000 miles per hour. That's lightning. It's basically a giant spark jumping through the atmosphere, carrying about 1 billion volts of electricity. Think of it like this. If you've ever touched a doorknob after shuffling across carpet and gotten a tiny shock, lightning is that same concept, just scaled up about 1 billion times, literally. But here's the question. If lightning is so fast and so powerful, why don't we hear it instantly? That's where thunder comes in. Okay, so remember that lightning bolt we just talked about. It's not just bright, it's hot. Like, really hot. We're talking about 30,000 Kelvin. That's 5 times hotter than the surface of the sun. When lightning tears through the air, it superheats the surrounding atmosphere in a fraction of a second. The air molecules expand so violently and so quickly that they create a massive shock wave. And that shock wave, that's thunder. It's basically the sound of air exploding. Pretty metal, right? But here's the catch. Sound doesn't travel nearly as fast as light. Not even close. Light travels at about 186,000 miles per second, or about 300 million meters per second, if you're into the metric system. Sound, on the other hand, travels at roughly 767 miles per hour, or about 343 meters per second at sea level. Let's put that in perspective. If light is a Formula One race car screaming down the track, sound is someone casually riding a bicycle. Sure, the bicycle's moving, but it's not even in the same league. So when lightning strikes, the light reaches your eyes almost instantly. We're talking about a tiny fraction of a second, even from miles away. But the sound? It has to travel through the air, molecule by molecule, creating that rolling boom we know as thunder. And here's where it gets practical. You can actually use this speed difference to figure out how far away lightning is. Here's the trick. Count the seconds between when you see the flash and when you hear the thunder. Every 5 seconds equals roughly 1 mile. So if you count to 5, the lightning struck about 1 mile away. Count to 10, 2 miles. It's not perfect. Sound speed changes with temperature and humidity, but it's pretty darn close. So next time you're watching a storm, try it out. You're basically becoming a human lightning detector. Pretty cool, right? But let's dig deeper into why this speed difference exists in the first place. So we've established that light is insanely fast and sound is not. But why? Why does lightning come first? Unlike your girlfriend, the answer comes down to what light and sound actually are. Light is an electromagnetic wave. It doesn't need a medium to travel through. It can zip through the vacuum of space at maximum speed. In fact, nothing in the universe travels faster than light. It's literally the cosmic speed limit. Sound, on the other hand, is a mechanical wave. It needs something to travel through air, water, solid objects. Sound works by vibrating molecules, and those molecules bump into other molecules, creating a chain reaction. It's like a massive game of telephone played by air particles, and that process takes time. The molecules can only vibrate so fast. That's why sound is so much slower. So when lightning strikes, both light and sound leave the source at the exact same moment. But light just absolutely smokes sound in the race to your eyes and ears. Think about it this way. In the time it takes sound to travel 1 mile, about 5 seconds, light could have traveled to the moon and back, twice, and still had time for a coffee break. The speed difference is so dramatic that for all practical purposes, you can assume you're seeing lightning the instant it happens, no matter how far away it is. But thunder has to take the slow road. And that's why, no matter what, you'll always see the flash before you hear the boom. But hold on, we're just getting to the good stuff. Let's talk about some wild lightning facts that'll blow your mind. Okay, myth-busting time. You've definitely heard the phrase, lightning never strikes the same place twice, right? Wrong. Lightning absolutely strikes the same place twice, sometimes even in the same storm. The Empire State Building gets struck about 20 to 25 times every single year. Tall structures are basically lightning magnets. And here's a wild one. There was a park ranger named Roy Sullivan who was struck by lightning 7 different times throughout his life and survived them all. 7. That's either incredibly unlucky or he really needed to rethink his career choices. Now, can you outrun lightning? Absolutely not. Remember that 270,000 miles per hour figure. Usain Bolt's top speed is about 28 miles per hour. You're not outrunning that. Don't even try. Here's a fun one. Lightning isn't always white. It can appear red, orange, yellow, or even blue, depending on what's in the atmosphere. Red lightning usually means there's rain in the air. Blue can indicate hail. It's like nature's mood ring. And why does thunder sometimes rumble for so long? Well, lightning bolts can be several miles long, and different parts of the bolt are at different distances from you. So you're hearing the thunder from each section arrive at slightly different times, creating that long, rolling rumble. Oh, and heat lightning. That's not actually a different type of lightning. It's just regular lightning from a storm that's so far away you can't hear the thunder, but you can still see the flash lighting up the clouds. Mystery solved. Last one. Positive lightning, which strikes from the top of a cloud, is actually more powerful than regular negative lightning. It can carry up to 1 billion volts and strike as far as 10 miles away from the storm. These are the real monsters of the lightning world. Now, with all this talk about lightning being awesome, let's switch gears for a second and talk about staying safe. Lightning is incredible, but it's also deadly. About 20 million lightning bolts hit the ground in the United States every year, and around 20 people die from lightning strikes annually. So here's what you need to know to stay safe. First up, the 30-30 rule. If you see lightning and can't count to 30 before hearing thunder, the storm is too close. Get inside immediately. Then wait 30 minutes after the last thunder before going back outside. When lightning is nearby, get inside a substantial building or a hard-topped vehicle. These create a safe shell around you. Don't bother with picnic shelters or small sheds. They won't protect you. Never stand under tall, isolated objects like trees, flagpoles, or in open fields. Lightning looks for the easiest path to ground, and that might be through you if you're the tallest thing around. If you're caught outside with no shelter, and this is a last resort, make yourself as small as possible. Crouch down on the balls of your feet, minimize contact with the ground, cover your ears, and close your eyes. Don't lie flat inside during a storm. Avoid using corded phones, touching plumbing, or using electrical appliances. Lightning can travel through wiring and pipes. Bottom line, respect the storm. That flash might be beautiful, but it's also powerful enough to vaporize sand into glass. Keep your distance, use the counting method we talked about, and always err on the side of caution. Now let's wrap this up. We've learned that thunder always follows lightning because of one simple fact. Light travels at 186,000 miles per second, while sound crawls along at just 767 miles per hour. It's not even a fair race. Lightning forms when electrical charges in storm clouds become so intense they explode through the air. That flash of light reaches your eyes almost instantly. But the thunder, the sound of superheated air expanding, has to physically travel through the atmosphere, taking about 5 seconds per mile. So remember, count the seconds between the flash and the boom, divide by 5, and you'll know roughly how many miles away the lightning struck. It's your personal storm radar. Now here's what I want you to do. Next time a storm rolls through your area, safely watch it from inside. Count those seconds and calculate the distance. Drop a comment below telling me how far away your lightning was. I want to hear your storm stories, and if you loved learning about this, smash that subscribe button and hit the bell so you don't miss our next videos. Thanks for watching, and remember, next time you see lightning before hearing thunder, you'll know exactly why. Nature's putting on a show, and now you're in on the secret. Stay curious, stay safe, and I'll see you in the next video.